Uranium is a chemical element with the symbol U and atomic number 92. It is a silvery gray metal in the actinide series of the periodic table. A uranium atom has 92 protons and 92 electrons, of which 6 are valence electrons. Uranium is weakly radioactive because all isotopes of uranium are unstable. The half-lives of its naturally occurring isotopes range between 159,200 years and 4.5 billion years. The most common isotopes in natural uranium are uranium-238 and uranium-235. Uranium has the highest atomic weight of the primordially occurring elements. Its density is about 70% higher than that of lead, and slightly lower than that of gold or tungsten. It occurs naturally in low concentrations of a few parts per million in soil, rock and water, and is commercially extracted from uranium-bearing minerals such as uraninite. In nature, uranium is found as uranium-238. Uranium decays slowly by emitting an alpha particle. The half-life of uranium-238 is about 4.47 billion years, and that of uranium-235 is 704 million years, making them useful in dating the age of the Earth. Many contemporary uses of uranium exploit its unique nuclear properties. Uranium-235 is the only naturally occurring fissile isotope, which makes it widely used in nuclear power plants and nuclear weapons. However, because of the tiny amounts found in nature, uranium needs to undergo enrichment so that enough uranium-235 is present. Uranium-238 is fissionable by fast neutrons, and is fertile, meaning it can be transmuted to fissile plutonium-239 in a nuclear reactor. Another fissile isotope, uranium-233, can be produced from natural thorium and is studied for future industrial use in nuclear technology. Uranium-238 has a small probability for spontaneous fission or even induced fission with fast neutrons. Uranium-235 and to a lesser degree uranium-233 have a much higher fission cross-section for slow neutrons. In sufficient concentration, these isotopes maintain a sustained nuclear chain reaction. This generates the heat in nuclear power reactors, and produces the fissile material for nuclear weapons. Depleted uranium is used in kinetic energy penetrators and armor plating. Uranium is used as a colorant in uranium glass, producing lemon yellow to green colors. Uranium glass fluoresces green in ultraviolet light. It was also used for tinting and shading in early photography. The 1789 discovery of uranium in the mineral pitchblende is credited to Martin Heinrich Klaproth, who named the new element after the recently discovered planet Uranus. Eugene Melchior-Pelago was the first person to isolate the metal, and its radioactive properties were discovered in 1896 by Henry Becquerel. Research by Otto Hahn, Lise Meitner, Enrico Fermi and others, such as J. Robert Oppenheimer starting in 1934 led to its use as a fuel in the nuclear power industry and in Little Boy, the first nuclear weapon used in war. An ensuing arms race during the Cold War between the United States and the Soviet Union produced tens of thousands of nuclear weapons that used uranium metal and uranium-derived plutonium-239. The security of those weapons is closely monitored. Since around 2000, plutonium obtained by dismantling Cold War-era bombs is used as fuel for nuclear reactors. The development and deployment of these nuclear reactors continue on a global base. There is increasing interest in these power plants as they are powerful sources of CO2-free energy. In 2019, 440 nuclear power reactors produced 2,586 terawatt-hours of CO2-free electricity worldwide, more than the global installations of solar and wind power combined. When refined, uranium is a silvery white, weakly radioactive metal. It has a Mohs hardness of 6, sufficient to scratch glass and approximately equal to that of titanium, rhodium, manganese and niobium. It is malleable, ductile, slightly paramagnetic, strongly electropositive and a poor electrical conductor. Uranium metal has a very high density of 19.1 grams per cc. Denser than lead, but slightly less dense than tungsten and gold. Uranium metal reacts with almost all non-metal elements in their compounds, with reactivity increasing with temperature. Hydrochloric and nitric acids dissolve uranium, but non-oxidizing acids other than hydrochloric acid attack the element very slowly. When finely divided, it can react with cold water. In air, uranium metal becomes coated with a dark layer of uranium oxide. Uranium in ores is extracted chemically and converted into uranium dioxide or other chemical forms. Usable in industry. Uranium-235 was the first isotope that was found to be fissile. Other naturally occurring isotopes are fissionable, but not fissile. On bombardment with slow neutrons, its uranium-235 isotope will most of the time divide into two smaller nuclei, releasing nuclear binding energy and more neutrons. If too many of these neutrons are absorbed by other uranium-235 nuclei, a nuclear chain reaction occurs that results in a burst of heat or an explosion. In a nuclear